Alright guys, so I'm going to continue with 9-3 solving quadratic equation by completing a square. This is the second part of it, and this second part focuses on the idea that what if the coefficient in front is not a 1? For the most part, if you looked over all the examples that I've shown you for the first part of this lessons, every single quadratic equation I have for you begins with x squared or a squared or b squared. It does not have any other number beside a 1 in front. And if I just write a squared, it means it's 1a squared, right? So our intended target is to have that coefficient in front to be a 1. And this is what I want you to focus on the actual format of a quadratic equation in its entirety. Notice that everything is in order from the greatest degree to the least, down to the constant, A, B, C in that order, and you need to remember the format. And it's like I said, the second target is to have the coefficient in front of the square term, the second degree term, to be a 1. If it's not a 1, we have to somehow turn it into a 1. So let's start with our first example here where everything looks okay, where we don't have a case where A is not a 1. And here's a first example. So the first thing I would look for is, do I have it in the right format? Is it in order from greatest to least? And that I have a 0 on one side, because when we're trying to solve for quadratic equations, we want to make sure it's in the right format, and we want to check to see if it's factorable first. And right away you can see here there's nothing that you can find to get a product of -14 and add up to 8. Because of that, we say that this is not factorable. Then we'll just jump to completing this completing the square. And the way that we do this is by completely remove this constant, move it over to the other side, so that we can find and come up with a new constant. So when I rewrite this equation, it'll look something like this. And remember the method I showed you before and how to find that constant, the new constant. It's just a matter of taking out the b coefficients right here in front of the x term, the first degree term, divided by 2, which will end up being 4, and then you square that to get 16, and that right there will be your new constant. But don't forget, this is an equation. If you're going to be adding in a new number, you have to do it on the other side as well. Okay, so we'll be adding onto both sides. So when I rewrite this whole equation again, it'll look something like this. Okay, and now this becomes a PST. You can kind of take a look. This is square root of 16 is 4. This is x. 4 times x double that, going to be 8x. So you can just write it as x plus 4 times x plus 4, or x plus 4 squared. We want to put it this way because we want to solve for x, right? And this simply becomes 30. Take the square root of this both sides. You end up with x plus 4 equals, don't forget the plus and minus cases here because of this, the square root, square root of 30. We cannot simplify 30, square root of 30, so we just leave it like that. Next thing we do is just minus the 4 over, and we end up with x equals to -4 plus or minus square root of 30. This will, you can split into two cases, -4 plus the square root of 30 or -4 minus square root of 30. If you want to do an estimation of square root of 30, that's fine, but I would definitely leave it like this, and it's fine, since I cannot simplify it at all. Next thing here I want you to try is to go ahead and do, well, let's actually, before I ask you to try something else, I want you to go ahead and see this next example. So here we go. Pretend now this is the case that I talked about. I have this case and I want to put it back into the right format, so I'm just putting everything back together with the 0 on one side. I just want to have the ax squared plus bx plus c equals 0 term. So I subtract the 2 over, and this is what I have. I looked immediately to see if it's in order. It is in order, and the a coefficient right here is not a 1. I can't complete the square. You can certainly try to do Xbox on it, and it's let's see. Well, pretend it's not working. Okay, pretend this is not factorable, or indeed it's not factorable. Then what you do is you have to make this into a 1, and the only way to make it into a 1 is by dividing by itself. But don't forget that because this is an equation, if you divide it by itself on one side, you have to divide every single term by that same coefficient. So what you end up with is x squared, because 3 divided by 3 is 1, minus 5/3 x minus 2/3 equal to 0. And now, it looks complicated, but we're just going to have to find our new constant so that it will become PST. So we'll go ahead and move this old constant over. It'll become x squared minus 5/3 x. Move it over, so you add it over, you end up with 2/3 on the other side. So how do we find our new constant? We take the b coefficient, we divide it by 2. Now remember, when divided by 2, we are multiplying by the reciprocal. So what you end up with is negative 5 over 6. And of course, the last step is to square it. You end up with 25 over 36. Okay? So this is our new c. What I do, I will add it in to both sides. So I'm going to rewrite my new equation as x squared minus 5/3 x plus 25 over 36 equals to 2/3 plus 25 over 36. Very important that you have to, if you add in one side, you have to add on the other side. This side now becomes a PST, and as you know, you take the square root of 25 over 36 to be 5/6, right? And 5/6 added to 5/6 will give you 5/3. It's automatically factorable, so you don't have to think twice about it. But then because this is a minus case, so you will have x minus 5/6 squared. Over here, this denominator will be 36. To make this 36, you have to multiply this by 12. So 12 times 2 on top will make it 24. I know I'm trying to work it out without writing it down, but 24 plus 25 is going to give you 49 over 36. Okay, so if you don't know how I got 49 over 36, work out this fraction problem on your own on the side. And the last step is to take the square root of both sides. You end up with x minus 5/6 equals to plus or minus the square root of 49 over 36 is going to be 7 over 6. Last step, I'm going to add 5/6 over, and that will end up being x equals to 5/6 plus or minus 7/6. They already have the same denominator. I can just go ahead and split that into two cases. Here's the positive case. 5/6 plus 7/6 ends up being 12 over 6 or 2. So that's one possible answer. The other case is the minus case. So it's 5 minus 7. 5/6 minus 7/6, which ends up being negative 2/6 or negative 1/3. So you have two possible answers for your x, and that's how you conclude this problem. Now what I want you to do is try this problem on your own. It's a short one, and I want you to follow the exact step. Okay, so try 2x squared minus 5x equals to 12. Now remember our procedures. We want to look for we want to make sure that this is a 1. If it's a 1, we don't have to divide or anything. But if it's not a 1, we would divide everything by that same number. Okay? And of course, we'll try to put it back into this format if we can, just because I want you to see the whole picture of it before we do anything else, to show that if it's not factorable, we would definitely find a new constant. We move the old constant to the other side. So try that out, and we're going to talk about this when you come back to class.